Let's begin by looking at the definition of a kite. Hopefully you can see why this shape is called a kite. It looks like the shape of a traditional kite. Some people also call the shape a diamond. It's a simplified shape often used to represent a physical diamond. I've tried to make the definition as simple as possible, and the definition of a kite is a quadrilateral with two pairs of adjacent sides that are equal in length. You can see it's a quadrilateral. There are four pairs of adjacent sides. Each pair of adjacent edges forms one of the corners of the kite. There's the adjacent edge pair that points upwards, the adjacent edge pair that points to the right, the adjacent edge pair that points downwards, and the adjacent edge pair that points to the left. But only in two of the pairs of adjacent edges do both of the edges have the same length, and that's a pair of adjacent edges pointing downwards and a pair of adjacent edges pointing upwards. And that's why we say that the quadrilateral has two pairs of adjacent sides that are equal in length. Let's indicate the equal edge pairs with some markers. So the top pair of edges are equal in length and the bottom pair are equal in length. And so now let's prove what the properties of a kite are. I'm going to lay the kite on its side because I find it easier to demonstrate the properties when the kite is in that orientation. Here are the list of properties of a kite. It's quite a long list, so I'm not going to read them out one by one before we start proving each of the properties. You can pause the video if you want to read each one of them. I'll be going through them one at a time, which will give us space to do any calculations we need to do. And once we've proved all of them, I'll bring the list back so you can see it again. The first property we'll look at is the one that says one diagonal produces two equally sized triangles. Let's put in a diagonal that runs from left to right, which will help us see why this is so. Adding a diagonal results in two triangles, and you should be able to see that the short edge of both of these triangles are of the same length, and that the long edge of each of these triangles are of the same length, and that the base of each triangle is just a diagonal that we just drew, so the length of their bases is the same. And when you have two triangles with the same three edges, they are identical in size, so this diagonal did produce two equally sized triangles. Instead of using markers to identify the edges, I'm going to give edges of equal length their own labels. I'll label the short edges A and the long edges B. And let's get rid of the markers. We can now move on to the second property, and that is that the same diagonal bisects the angles it passes through, which means that the diagonal we just used must split the angle on the left into two equal parts and must split the angle on the right into two equal parts. Let's show the angles. Now both of these are composite angles, each made up of two values. And remember that the diagonal produced two equally sized triangles, one at the top and one at the bottom. Now when two triangles are congruent, it also means that corresponding angles in the triangles are equal. If we consider the top triangle, the angles that are shown are base angles in that triangle. I'm going to label those angles. The base angle on the left is C, the base angle on the right is D. We can describe the angle C in another way, and that is the angle between the edge A and the base. But that means that in the bottom triangle, the angle between the base and the edge A must also be C. The same goes for the angle D. It's the angle between the edge B and the base. So in the bottom triangle, the angle between the edge B and the base must be D. Now, if we look at the whole of the left angle and the whole of the angle on the right, we can see that they are divided into two equal parts. And that satisfies the second property that the diagonal bisects the angle it passes through. Let's move on to the third property, and that is that kites have one pair of equal opposite angles. This is not difficult to demonstrate. You simply have to remember that the two triangles are identical, and so corresponding angles must be identical. The only angles in the triangles that we haven't considered are the angles that are opposite the base in each triangle. And since in both triangles these are the angles opposite the base, they must be corresponding angles, and therefore they must have the same value. I'll give them the label E, but notice that these two angles, which are identical, are opposite angles in the kite. And so that satisfies the third property, that a kite has one pair of equal opposite angles. So we've demonstrated the first three properties out of the 6. And now let's demonstrate properties 4, 5 and 6. The fourth kite property is that the other diagonal, which we haven't drawn yet, produces two isosceles triangles. You'll see clearly why this is once we've added the diagonal. So we've added the diagonal, but things are a little bit crowded. So I'm going to clear most of these angles. Now the second diagonal, the red one, has indeed produced two triangles, one on the right and one on the left. Let's examine them both. The one on the right has two edges of length B and the base. And we know that a triangle that has two edges of the same length must be isosceles. So the triangle on the right is isosceles. If we examine the edges of the triangle on the left, we see that it has two edges of length A and it has the base. So this triangle must also be isosceles. And so that satisfies the fourth property, that the other diagonal, which we just drew, produces two isosceles triangles. Now let's move on to property number 5. Property 5 is that the diagonals of the kite intersect at right angles. This one isn't as easy to see, but given that the recently added diagonal produced two isosceles triangles, we can use a special property of isosceles triangles to show that the diagonals do in fact intersect at 90 degrees. To do this, let's first bring back the left side angle values and the right side angle values of the kite. Now the angles that we just introduced are also the angles in the two isosceles triangles that are opposite the base of both triangles. The angle of size 2D is opposite the base in the isosceles triangle on the right, and the angle of size 2C is opposite the base in the isosceles triangle on the left. In both cases, the angle that's opposite the base is bisected by the first diagonal. In an isosceles triangle, this property leads to a useful result. Here's a property. The angle bisector that passes through the base is perpendicular to the base. An angle bisector splits an angle into two equal parts, which is the case in both of the isosceles triangles. And what that property says is that if that angle bisector passes through the base, it is perpendicular to the base. Well, we can see that in both of these isosceles triangles, the angle bisector passes through the base of the triangle, which means that the angle bisector is perpendicular to the base. The base is one diagonal in the kite, and the bisector is the other diagonal in the kite. So the diagonals are perpendicular to each other, and therefore they intersect at right angles. And that satisfies the fifth property, that the diagonals intersect at right angles. Let's drop the right angle in, and now there's just one final property. Property 6, one diagonal bisects the other. And we can use the fact that the two triangles created by the yellow diagonal are identical in size to prove that the yellow diagonal bisects the red diagonal. Now the height of a triangle can be given by the length of the line that is perpendicular to the base and passes through the vertex that's opposite the base. And so in the top triangle, the red diagonal, which is perpendicular to the base, passes through the vertex that's opposite the base. So the part of the diagonal that's inside the upper triangle must be the height of that triangle. But we have exactly the same situation in the lower triangle. The part of the red diagonal that starts from the base and is perpendicular to the base passes through the vertex that's opposite the base. So that must be the height of the lower triangle. Let's label the triangle heights. We'll say the height of the top triangle is h1 and the height of the bottom triangle is h2. But we know that these two triangles are identical in size, so their heights must be identical, which means that really h2 is the same length as h1. So I can replace the value of h2 with h1, and now you can see that the length of the red diagonal either side of the yellow diagonal is h1, so the yellow diagonal bisects the red diagonal, and that satisfies property number 6, one diagonal bisects the other. And so the list of properties are complete. There are more properties. Perhaps in the future I'll make another video with more advanced properties. Well, that's it for now. Thanks for watching.